Hello, Stat 200, and welcome to Lesson 8. The title of this week's lesson is Inference for Proportions and Means. This week, we'll be applying the central limit theorem and using the z and t distributions to construct confidence intervals and conduct hypothesis tests. When sample sizes are sufficiently large, these are the preferred procedures. These are all covered in Chapter 6 of the Lock 5 textbook. Let's start with a quick review. These are the general formulas for confidence intervals and test statistics. All of the tests that we'll review this week will follow these general formats. These are the key topics that you'll learn about this week. These should look familiar because you've been working with these since Lesson 4. For each of these topics, we'll cover confidence intervals and hypothesis testing. In this video, I'm just going to give a quick overview with the assumptions for using the common distributions that you learned about last week. Let's start by looking at one sample proportion. If n times p and n times 1 minus p are both at least 10, the sampling distribution can be approximated using a normal distribution with a standard error of the square root of p times 1 minus p over n. If this assumption is met, then we can use these formulas to construct the confidence interval or compute the test statistic. Note that these are the same formulas that you saw last week. Now we're just plugging in the formula for the standard error, which may be applied when n times p and n times 1 minus p are both at least 10. If n times p or n times 1 minus p is less than 10, the sampling distribution can be approximated using a binomial distribution. You were introduced to binomial distributions last week. Minitab Express refers to this as the exact method. We won't be doing the exact method by hand in this course, but you will see how you can use Minitab Express to conduct this type of test. For one sample mean, if the sample size is large, at least 30, or if we know that the population is normally distributed, the sampling distribution will be approximately normal with a standard deviation of sigma over the square root of n, where sigma is the population standard deviation. Most of the time we don't know the population standard deviation, so we need to estimate it using the sample standard deviation. The formula that you may see in these cases is S over the square root of n, where S is the standard deviation in the sample. Because we will need to estimate the population standard deviation using the sample standard deviation, we use a t distribution to approximate the sampling distribution. A t distribution is similar to a z distribution in that it is bell-shaped. However, the height of the t distribution changes depending on the degrees of freedom. For a one-sample mean test, the degrees of freedom that are used to determine the height of the t distribution are equal to n minus 1. These are the formulas that we will use to construct confidence intervals and compute test statistics for one sample mean. Again, these follow the same general formats that we've been using for a few weeks now. For the confidence interval, we have the sample statistic, plus or minus the multiplier, which we will be getting from the t distribution, times the standard error. For the test statistic, we have the sample statistic minus the null parameter divided by the standard error. If the sample size is small, less than 30, and we don't know if the population is normal, you should use bootstrapping or randomization techniques. In previous weeks, you've used these procedures in StatKey and Minitab Express. In special cases, such as with standardized tests, the population will be normally distributed and the population standard deviation will be known. In those cases, the sampling distribution can be approximated using a z distribution. This is known as a one-sample mean z-test. There's an optional section in your online notes this week that covers the one-sample mean z-test. It's used often in the fields of education and psychology where we have standardized tests with a known population mean and a known population standard deviation. In other fields, you may be much less likely to see this type of test. In Lesson 1, we learned the difference between independent and matched paired designs. Paired samples, also known as dependent samples, can involve taking two measurements on the same participant, or it can involve matched data, for example, mother-son pairs or husband-wife pairs. You've seen some of these examples in StatKey, but StatKey treats these as single sample designs because the formulas and the procedures are the same with the added first step of computing differences. Like the single sample mean test, if the sample size is at least 30, the sampling distribution can be approximated using a t-distribution. These are the formulas that we're going to use for paired means tests. Note that these are the same as the single sample mean formulas, just now you have a subscript d from the mean and standard deviation. The subscript d stands for difference. The degrees of freedom will be n-1, where n is the number of pairs. For two independent proportions, if n times p and n times 1 minus p are at least 10 in both groups, the sampling distribution can be approximated using a z-distribution. These are the formulas that you'll see this week. The formulas are getting a bit more complex now, but remember that Minitab Express will do these calculations for you. One thing that I do want to point out in the formulas is that when constructing a confidence interval, the sample proportions are used to compute the standard error. For computing the test statistic, we need to compute what is known as a pooled proportion. This difference is because the hypothesis testing assumes that the population proportions are equal. Recall, the null hypothesis is that the proportion in group 1 equals the proportion in group 2. Therefore, they should be estimated together. Confidence intervals, on the other hand, are not constructed under that assumption, so we estimate those proportions separately. You should pay special attention to this when using Minitab Express because you will need to tell it whether you want to estimate the proportions separately or if you want to use a pooled estimate. Finally, for two independent means, if both sample sizes are at least 30, or if the populations are known to be normally distributed, the sampling distribution can be approximated using a t-distribution. Here we have our formulas. Again, these follow the same general formats that we've been working with. For the confidence interval, we have the sample statistic, plus or minus the multiplier, which again we'll be getting from a t-distribution, times the standard error. The degrees of freedom here, we will estimate using the smaller sample size minus 1. Minitab Express uses a more complex formula, so note that if you conduct this test by hand, your results may be slightly different from the results obtained using Minitab Express. For the test statistic, the population parameter is 0, because the null hypothesis is that there is no difference between the two means. So we have our sample statistic divided by the standard error. Those are all of the topics that we're going to cover this week. Before I leave you, I want to share a few strategies that can help you get through this week. First, start by assessing the research question. Identifying the variables correctly is key. There are quite a few questions on the quiz this week about selecting the correct procedure. You'll also see this on the final exam. You need to be able to assess the situation and identify the correct test before you can do anything else. Pay attention to the similarities. You will see many formulas this week. Always look for the similarities. The structures of the formulas for confidence intervals and test statistics are very similar this week. And when possible, use Minitab Express. Minitab Express can be used to do all of the calculations this week. For the lab assignment, and even on the quizzes and Wiley Plus homework assignments, you can use Minitab Express. This concludes the Lesson 8 overview video. As always, if you have any questions this week, please post them to the Lesson 8 discussion board in Canvas.